Hi everyone, and welcome to this video where I'll be taking you through what the bisection method is and why do we use it. So the bisection method is a way for us to find approximate solutions to functions. In a graphical sense, what this means is we're trying to find the x-intercepts of this particular function. The work that we've been doing throughout polynomials and even prior to this in quadratics, we've been working through algebraic methods to find the solution, the exact solution. What we're looking at is a way of us doing this by investigating a graph. And the reason why we're doing this and the reason why it's a process that we have access to and why it can be used is sometimes there are very complex functions out there where typical solving techniques just aren't time efficient, or they're going to be really super complex. In this way, what we can do is we can set up spreadsheets or a program to help us find approximate solutions to certain decimal places or degree of accuracy as well. I'm going to take you through what the bisection method is, and the best way that I find to explain it is with a graph. So let me set up a set of axes, and my program here will make nice straight lines, which is awesome. There we go. All right. So let's say we have a function, and it's doing lots of different things, but it does go through the x-axis at some point. So we've got our x and our y-axis. And we are obviously pretty interested in whatever's happening at this point. That's the solution we're trying to find. Now, this function, whatever it might be, we want to find the approximate answer because the solving may just not be the best way to go about it or the most time efficient. So what we do is we take a look at the graph, or we investigate certain sections of it to say, is there a solution between these two x values or in this interval? So let's say we are interested in the interval from a and to b. Now, at x equals a, on the curve we have a coordinate which we call a and f of a, and f of a just means we've replaced x with a and we've worked out what the y coordinate is going to be. And actually, let me just label the curve as f of x. Okay, here at b, so let me just put some dashed lines here. Here at b, this would be the point b and f of b on our curve. Alright, so we've looked at this curve, we've done some investigation, and I know that there's a solution between a and b, and this is why. At a, the y coordinate is positive. It's above the x-axis. At b, the y coordinate is negative. It's underneath the x-axis. Now, the only way that my curve goes from a positive y value to a negative one is because somewhere in between a and b, it had to go through the x-axis for it to go from above to below. So I know somewhere there is a solution in between a and b. I don't want to investigate every single little point in between a and b, so we use the bisection method. Bi meaning two, section. So we're going to split our section into two, and we do it exactly in half. So what we do is we work out the midpoint, the halfway point between A and B. So I'm going to call this new point C. And C also has a corresponding point on our curve. The y coordinate is FC, and the x coordinate is C. Alright. So now what we do is we're going to investigate. Okay, let's take a look at this interval between C and B. Is my solution there? Well, the y-intercept of C is negative, and so is B. So the curve doesn't seem to have gone from negative to positive because our two y coordinates, when we look at these endpoints, the left endpoint is C and the right endpoint is B, they're exactly the same sign. They're both negative, which means I'm not going to see a solution there. If we take a look at the interval between A and C though, A and C, A has a positive y coordinate and C has a negative y coordinate, which means that our solution is going to be sitting between A and C. And the interval A and C was half of the original interval A to B. And then we repeat the process. So from here on out, we're going to be focusing on the interval from A to C. We again split it, so let me grab a pen, and we split it. So let's say the halfway point is there at D. Pretty close to the solution, but I may not know that. So let's say this is point D, and D is halfway between A and C. The coordinate here, let's say that this is the coordinate D and F of D. And we repeat the process. Well, between D and C, the y coordinate on the left endpoint at D is positive, and at C, the right endpoint, it's negative. So I suspect my solution is between there. Let's double check though with A and D. The y coordinate of A is positive, and so is the y coordinate at D. So my solution is not going to be between A and D. That means from here on out, I'm going to repeat the process looking at the interval D to C. And I would halve it again and follow that same process. And what happens is that interval gets smaller and smaller and smaller every time. And the way that we approximate is when your left endpoint, your right endpoint, and your midpoint are all the same value correct to a certain amount of decimal places. So you will be asked to complete these to find the approximate solution correct to a certain number of decimal places. Every time you're halving the interval, you're checking both halves. You then select, okay, my solution was in between this one, this interval. I'm now gone to this. Which one is it? Well, let's say it's this one. Great. We've now halved the amount of x values for us to investigate, which is awesome. It means we're getting closer and closer to our solution every time. We halve it again, and we check the interval and the left and the right endpoint. We're checking the y values. The solution will be between 2 points as long as the y in coordinates are opposing or different signs. One positive, one negative, and it might actually be the other way around, depending on how your graph has been sketched. So that's the bisection method. We're halving the interval to try and get as close as we can to the solution every time. And it's what we call an iterative process. It's the same process repeated until we get the level of accuracy that we're after. You'll see how to use the bisection method by hand with the use of CAS to help you out, and also a method of just purely using the CAS list and spreadsheets and programming it to search for and compare these y values, just like I've explained here. But that is it for the bisection method. Be sure to rewatch this video if you need further clarification, or to look at Ed Rollo. There are some videos there too about the bisection method. But that is it for now, and I'll see you in one of the videos down below.